Today we're looking at hard problem. So we have a string like this, and we have queries. Query to change at positions, query ice, position, for example, 1, 2, and query characters to replace. For example, at position 1 we want to replace 0, 1, 2, A to B, set B, and at position 2 we want to replace B to A, for example, like this. And all the queries are invoked consequently, and their results are saved. So this is not independent. We should run them one by one. So for the first position we change A to B, and we want to answer what the longest same character subarray we have. For example, initially we have 3, and when we change A to B we still have 3, and then we change at position 2 B to A, and we still have 3 because this is C, it gives us 3. But if we remove C, we have initially 2, and after we place B, we have 3 of B, and then we have again 2, because we have 2 C, and if we remove other C, we have 1. So this is a hard problem. Has 10 to the power of 5 string length. I personally didn't solve it because I don't know segment trees. I tried to solve it with union find, and this is not work because we have to disconnect. Because if we have, for example, B, 3 B's, and they ask us to put instead of second B, we put A, and that disconnects the entire sequence of B's and goes from 3 to 1, and this is not solvable with union find. Again, not applicable. And the solution is segment tree. I personally didn't solve it. Again, I said it again. I tried to understand, explain what I understood, how this is solved. So imagine we have put all the positions into the nodes leaves of the segment tree, leaves of segment tree. So basically each position is the leaf, and then we going up to build a segment tree. I call that push. It can be push up. Basically it takes splits like into half. So we have and by the way we have to keep, okay, anyway, forget it. We split it by half, and we're saying this is a root, and then again we split it by half and saying this is a root, and again and again. So like this, and then like this, and then like this. This is how segment tree goes. And when we going backwards, and this is depth first, and then we have post order traversal, and we're going up, and then we can track what should we track, and we're tracking the maximum for each. So initially maximum in each leaf, the maximum is 1. maximum is the maximum of repeating character in this range. By the way, each node has their own range, and each node would have the maximum. For example, for this node, maximum would be 2 because it has 2A, 2Bs. This is how it works. And not only that, we have to merge the repeats between left and right to successfully detect where the maximum is. And for the merge, we have to track the prefix and the suffix repeatance, because we merging suffix of the right suffix with prefix of the left prefix, and then we merge it together and it became one. And let's look at the code, how it looks, how this is done. So we have if the characters match between left and right, we do merging the prefixes first. Prefix of the current parent equal prefix of the left suffix. So left. No, this is the left suffix. Okay, and this is a right prefix. And we merging this left suffix with a right. Oh, sorry, this is a prefix of the left, and this is a prefix of the right. This is the prefixes, by the way. And if we imagine it only if the entire length of the left subtree equal to the prefix of the left subtree. So entire prefix is a match. Then we merge it. And same for the suffixes. And maximum is taken if we have a match. We are merging this suffix of the left with prefix of the right. This is a push. And initially we do the build. So basically, as I said, this is like it goes deep first, and in the post order it goes up with push operation. This is a post order traversal. So it first goes deep, and then it goes up and merges. This is how it built. And then we do modifications, and we do update. The update is the same as build almost. We go and we search for the index that we updated, like if it's to the left or to the right, and in post order we are popping up, like, or push up, and then we just taking the maximum of the root. Okay, I think I have already streak of 1699 days, and I still don't know how to apply segmentaries and don't know how to write them on my own. This is a huge gap in my knowledge. They're just so rare, and I don't have a reason to actually learn it with my muscle memory. It could be worth it. By the way, the binary indexed tree also is not applicable here. Bit. because the binary indexed tree is good for the ranges of from 0 up to I, and this is a segment tree, and it's get updates by binary searching the position that was updated. So it goes and do binary search, and then it pops up. So okay, that's it for today.